TNT sitting there. What form of energy is this? You know? Yeah, chemical potential energy, right. Okay, I like that. Now what form is the energy? We've exploded. I'm sorry you can't see this very well. We've exploded, all right? There's a flash here, there's things moving away. I'm implying a bunch of different, so what are the different types of energy now? There's kinetic energy, but what specifically in here is kinetic energy? Well, but let me get back to the kinetic energy. When we say kinetic energy, which part of this do we really identify as kinetic energy?
The movement of pieces.
These pieces flying away, right? Big objects flying away. Okay, so what other types of energy? Thermal, great. Heat's being created, all right, which is another type of active energy. What else? Absolutely. There's going to be sound waves moving away from this explosion. And what else? One more. Light. Right, there's light, okay. So, again, this is a beautiful example, although a violent example, of a conversion of some potential energy into a whole bunch of different other types of energy. Okay? And a lot of what you're going to be doing in your activities today, you're going to see some of and I'll talk a little bit more about the activities and the questions and the comments that I'm going to ask you to think about. One of the things that I ask you in those questions is kind of diagram out or talk about the energy and energy transfer in the process. Okay, how it goes from one form to another form to another form. Okay.
I have a question.
Yeah.
Do you use the word mechanical?
Yeah, I do.
Because again, the sixth grade textbook, the book I think does a very poor job. My rating is too big, but they say that mechanical energy is the combined potential and kinetic energy in objects. That they kind of they sort out that the movement of objects.
Yep.
Is mechanical, it's the movement of something else, like particles or...
Yeah, so I would say, so mechanical energy, the way I think everything, so I would be more specific, but that definition I like, potential plus kinetic energy, but I think specifically what they're talking about is, in the case of mechanical energy, the potential energies you're typically talking about are gravitational and elastic. Okay, so in that way I would be happy calling, so I would call elastic potential energy, gravitational potential energy, and kinetic energy, mechanical energy. All of those together. Does that make sense? Does that answer your question?
But movement of objects versus...
Yeah, heat is movement of objects, but microscopic ones. So we talk about that differently. So that's not really mechanical energy. So heat is its own thing that I wouldn't lump into mechanical energy. Does that answer your question? Let's talk more about it if you have specific questions. All right, we've already talked a little bit about this. I'm glad that you all have a sense of spring energy or elastic energy, because that's going to be involved with your first activity. Actually, let me bring this up. Let's just talk about this process. Pendulum. We've talked about pendulum in previous classes. Let me see if I can do this without destroying my laptop. All right, so this process here. I mean, this is a simple thing, but it's important for you to be able to talk about. So there's a lot of interesting energy conversions that are happening in this process. So let's talk about the pendulum. When I bring it up here, what do I have? Does this object, this mass, let's just talk about the mass at the end here. Does it have energy?
Potential gravitational energy?
Yes.
Does everybody like that answer? All right. Now I'm going to release it. Okay. So what's happening now? Let's talk about different parts of the process. So do we have kinetic, when I'm holding it, we have kinetic energy?
No.
Okay. Now as it rolls down to the bottom, right here, do we have kinetic energy?
Yes.
All right. Is it the most kinetic energy, the least? How much do you think it is? The kinetic energy. Probably the most, right? Because you're going the fastest. Okay? At the bottom. When we get up to this point, What form is our energy? So we go from potential to yeah, so you have this is an energy conversion machine here, right? It's converting between potential and kinetic energy over and over again, okay? And you can think about the potential energy also as the height of this object. That's where it's getting its energy. It's able to release energy and get it back, okay? It releases the potential energy, and then it climbs back up a little bit, and releases it again, and releases it again. A powerful way of thinking about this is sometimes you want to think about energy as sort of money in a bank account. You have energy in your energy bank account, all right? You've got potential energy. You can pay some of that out, and you get moving, all right? But now you're actually putting money back in the bank, right? As you move back up in height. And so it converts back and forth. Now, will this go all day?
No.
Why not? Friction is an answer. There's an answer out there, friction. Is everybody? So what friction? Where's the friction?
Air resistance and with the plate resistance.
Up here?
Yeah.
Okay, so how do we talk about this in terms of energy?
Energy is being changed from one form into another.
What form into what form?
The
So-
movement of the strings of that kinetic energy into thermal energy at the top.
So you think you're heating things up here, that's where you're losing it. Everybody like that? Or not like it? It sounds a little weird that you're heating. You're absolutely. So I agree with that too. Some of the energy is being transferred to air particles. Okay? That you're actually pushing on air particles. I mean, it's kind of a form of heating, if you want to think about it that way. But you want to think about where does this energy go? And I think the idea that you're heating up here is actually a good one. It's probably not something you're going to feel with your hands. It's going to be a very, very small amount of heat that's being lost up there. But the energy is going somewhere. It's also going to friction with the air. And so one way of thinking about it is you want to think about the molecules. This big object moving through the air is pushing things. Okay? And so it's losing energy to those particles. Okay. So this has been, I think, a pretty good introduction to this concept of energy. Part of what we're going to do in these activities today is think about qualitatively, like how to talk about energy conversions from one type. The way I want you to think about what you're doing in these exercises is think about the different forms of energy at each point in the process. One of the things I ask you to do in some of these exercises is diagram things out. And what I mean by that is think about the different, like we did here, there's different parts of the process. Step A, B, C. What are the different forms of energy through the process? Okay? And think about which types of energy are higher or lower, what's being converted into what. Okay, so I think what we should start doing, this first exercise we're going to do every group's going to do it in parallel. We're going to do this a lot like we did the electricity and magnetism session, where we do one activity all together, and we'll talk a little bit about it at the end, and then you're going to break out into this round robin of activities. So this first activity we're going to do, essentially you're just dropping these super balls, okay? And you've got Play-Doh, super balls, and measuring tape. The instructions are there. One of the things I do say is it would be nice to do this on a hard surface. I guess you could do it off the table, or you could do it outside. And there's hard surface back here for a few groups. It'll make the exercise a little more interesting if you have. And we can talk about why the rug's not a good surface. It has a lot to do with energy. All right, so let's break out, and then we'll come back.